Hi guys, welcome to Abstract Algebra. Today we're going to talk about the basic information and definitions about rings. A ring is composed of a non-empty set R and two binary operations defined on R, additions and multiplications. There are three things we need to satisfy. Firstly, R with additions is an abelian group with a additive identity at 0. Secondly, R with multiplications are associative. And thirdly, this has to follow the distribution law. Here are several examples of rings. Number 1, the ring with an unit element. Here the unit element referring to the multiplications identities, meaning that if 1 in R is a multiplicative identities, then 1 times A equals to A times 1 equals to A. Number 2, commutative rings. If a ring is commutative rings, then the multiplications of that ring is commutative. So for all elements in that ring R, A times B equals to B times A. Number 3, division rings. Division rings has two properties. Firstly, it has a unit element. And secondly, it has a multiplicative inverse for every non-zero element, meaning that for all non-zero elements in R, you can find an inverse in R such that if you multiply them together, you got the unit element 1. Number 4, integral domains. Integral domains are commutative rings without zero divisors. We say two elements in a ring are zero divisors if firstly they are non-zero, and secondly if the multiplications of these two elements equals to 0. So here is an example of zero divisors. In the ring Z6, which is the integer module 6 rings, we have elements 0 to 5. In this set, 2 and 3 are non-zero elements, but 2 multiplied by 3 equals to 6, which is 0 in this set. So 2 and 3 are non-zeros, but the multiplications of 2 and 3 is zeros. So 2 and 3s are zero divisors. Number 5, fields. A field is a commutative ring with an unit element and multiplicative inverse for every non-zero element. Something to notice is that a field has at least two elements, one additive identities and one multiplicative identities. Here is the summarization table. Now we're going to introduce the idea of units. The units here are different with the unit element 1 we saw before. So a unit, or you can also call it invertibles, are the element in a ring that has multiplicative inverse. And the notation of R with a upper right cross denote the set of all units. So for example, in the ring of integers with the normal additions and multiplications, the set of units are 1 and -1. Because for all other elements, such as 2, 3, or 4, etc., its multiplicative inverse are 1/2, 1/3, or 1/4, which are all fractions, which is not in the integers. So the only two units of z is 1 and -1. Next idea we're going to introduce is subrings. For any ring R, R prime is a subring of R if it is satisfied the two following conditions. First, R prime with additions is a subgroup of R prime with additions. And secondly, R prime is closed under multiplications, meaning that for all elements A and B inside R prime, A multiplied by B is also in R prime. Lastly, we're going to introduce ideals. For any ring R, I is an ideal of R if the set I is a non-empty subset of the set R and it satisfies the following two conditions. Firstly, I with additions is a subgroup of R with additions, and secondly, for all element in I and for all element in R, the left-hand side and right-hand side multiplications of those two elements should all belong to I. Well, thank you guys for watching. You can email any questions, concerns, or advice to the email below. I'll see you in the next video. Bye!